Okay, now it's time for some trigonometric identities. Now, here's a right triangle again. Once again, these are going to be based for a right triangle. We have others that are for obtuse triangles, but we're not there yet. Now, trig identities have funny names. And there's what connect your buttons on your calculator that say sine, cosine, and tan. You've probably been wondering what the wires have a sin button on your calculator, and it has nothing kinky, I promise. So, it's just different trigonometric functions, sine, cosine, and tan. And like I said earlier, these are all based on ratios for the different lengths of the sides of the triangle. It's a function that gives you the ratio. If you know an angle, it gives you the ratio of two sides. Depending on which function you use, depends on which sides it does. So here are the definitions for all three of them. And we use our special names for the sides of a triangle to help us out here. So sine of an angle is equal to the opposite over a hypotenuse. So the opposite side over hypotenuse, that ratio is equal to the sine of that angle. The cosine of an angle, adjacent over hypotenuse. So that ratio. And tan of an angle is the opposite over adjacent. So tan connects these two sides. I'm going to just do it for this angle right here. Cosine connects these two sides. And sine connects these two sides. So you can see with those three trig identities, I have all the sides connected. Now, something I'm going to go ahead and tell you, I'm not in class with you to help you with this, you have to be very careful with your calculator because it either has your angles in radians or degrees. What are radians? Well, it's just a different way of telling an angle. The easiest way to tell is to type this into your calculator. Type in sine of 30. If that does not equal 1/2, then you are in radian mode. How do you change that? I would definitely look it up online. You can email me. I'll help you with that. But you need to switch it to degree mode because that's what we're going to be using in this course. Degrees are much easier for us in this course. So if it pops out that it's equal to 1/2, you're good. So sine of 30, if you plug that in your calculator, it should equal 1/2. Okay? If it does not, then you are in the wrong mode and you'll have to figure out how to change that. It's not usually too difficult. You'll usually see a mode button on your calculator. And if you scroll down a little bit, you'll find something to switch from radians to degrees or vice versa. Cool? Okay, so we got that. We have our functions here. We've written them down. And we now know that these are all just ways of connecting the ratios of different angles or different sides based on what the angle is, based on the angle we're looking at. Now, like I said earlier, if we were doing it for angle B right here, sine would be equal to B over C, cosine would be A over C, and tan would be B over A. So make sure that you are being careful of those. I would strongly suggest that while we are going through this section of the course, that you really try to write down the names of the different sides to help yourselves do this. Now, do you think it's going to be helpful or not? I promise you it will be. So let's try it out. Now, here's a basic trig example. I know one side and I know one angle. Why do I know those angles? Well, maybe I know based on a distance measurement that something is 5 meters away, and I have some sort of angle measurement that tells me what angle it is from the floor. Well, I want to know how high up it is to the ceiling and how far away it is from me to that point. Can I figure this out? I can actually. I totally can. So let's work out this example. Now, an important thing to do is probably to go ahead and name our sides, okay? And the reason we want to name our sides is because we can't just use Pythagorean theorem here. We don't have enough information to use that. So tan of 30 is equal to opposite over adjacent. Well, this guy would be the opposite side. This would be the adjacent side. That's just me abbreviating it. Sine would be opposite over hypotenuse. Okay. And cosine would be adjacent over hypotenuse. And what you realize if you look at this is, well, this one I don't have enough information. I'm missing too much stuff to solve anything. But for the other two, I only have one unknown, the adjacent or the opposite side. So if I plug that in my calculator, I can actually use my trig identities to solve for the sides of the triangle. Whoop. So let's go ahead and do that. So right here, what I'm going to see is if I solve this equation, I get that my opposite is equal to 5 sine of 30 degrees. My adjacent is equal to 5 cosine of 30 degrees. I usually put it in parentheses at the end of the first one. There we go. So let's go ahead and see what that is. So 5 sine of 30 comes out to be 2.5. Okay, so this side is 2.5. The other one, 5 cosine of 30, is 4.33. Fantastic. Now, for those of you who are very visually minded, you're going to be very, very angry at me because you look at this and say, this is not to scale. Yes, it is not to scale, okay? I could not make pictures that would automatically update to be scaled for each problem. So just know that I give you a picture of a right triangle or an obtuse triangle when you're doing the problems. That's just to help you visualize it a little bit. But if you really want to, you can rewrite or redraw it if you need to. I don't have the ability to make it automatically update. And since I have randomized numbers, there's some times where it completely is strange like this one where it would have made more sense for me to have the opposite way. It is how it is though. Okay, so we're going to stop here. We've gone over our trig identities. And next time we're going to jump into some more practice. So I'll see you then. Bye-bye.